each of 1 through 4, find a counterexample to show that the statement is false. Assume all sets are subsets of a universal set U. For all sets A, B, and C, A union B intersection C equals A union B intersection C. I think the best way to approach this is to see why visually with a Venn diagram these two sets are not the same, and then we can build our counterexample based on the pictures. So A union B here would be everything in both A and B, so that'd be all of this region here, and that intersection would be this region here. Now let's take a look at the other side. B intersection C is this region here, and we want to combine that with A. So we would also want this region here. Now visually, we can see that on the right side, there are elements that are in A and not in B and C, whereas with the left side, there are no elements that are in A that aren't in B and C. And so when we construct this, we need to make sure that A has elements that are not in B and C, and that way we should be able to see why these two sets are not equal. So here are 3 sets that I made up. I picked B and C completely randomly, but I picked it in a way so that A has elements that are not contained in either B or C. Now what we're going to do is we're going to compute the left-hand side here. A union B would just be 1, 2, 3, and then A union B intersection C would just be 3. The right-hand side here could also be evaluated separately. First, we can evaluate what B intersection C is. This is everything in B and C, which is just 3. And then we can add A union B intersection C, and then we can combine that set with A to get 1, 2, 3. And if you notice, these two sets are not equal to each other. There are elements in the blue set here that are not in the red set. And therefore, these two sets cannot be equal for all sets A, B, and C because we have a counterexample. Thanks, everyone, and I'll see you in the next video.